Hello class and welcome back to section 8.6, solving rational equations and inequalities. We are now on the back side of our note sheet. We're going to go ahead and do problems 6 through 9. I would recommend that if you like to write a lot or if you write big, to grab an extra sheet of paper and do examples 6 through 9 on a different sheet of paper, because otherwise if the space is a little too crowded. The problems 6 through 9 are different than the front just a little bit because there's going to be factoring involved. Okay, so let's go ahead and look. It says solve the rational equations, eliminate extraneous solutions. So we should know, well, what is an extraneous solution if I need to eliminate them? It is a solution that is created by multiplying by the LCD, but is not an actual solution to the original equation. Usually it's a solution that if you plug it back in, you're going to get a 0 in your denominator. So in this case right here, if I got -1, well, if I had r equals -1, -1 plus 1 is 0, I would have 0 in my denominator, and you cannot divide by 0. So that would be an extraneous solution. So when you're done getting your solutions, you need to come back, go back to the original problem and check to make sure that doesn't happen. Okay. So let's just go ahead and start example 6. First thing I would do is I would factor the denominators. This is going to be r plus 1, this is r times r minus 1, difference of perfect squares, and this is r plus 1. So now, to get my least common denominator, I would think, well, what would I have to have for all of them? This is, remember, r over 1. Well, it would have to be r plus 1 times r minus 1. Okay, or the other way you can think about it as r squared minus 1, depending on which is easier for you when we're writing it out. Okay, so I would have r. And since these multiply to give me r squared minus 1 and it's not going to cancel anything, I'm going to leave it as r squared minus 1 plus, I have r squared minus 5. Now if you look here, this is r squared minus 1, the denominator, so I'm going to leave it written as r squared minus 1 all over r squared minus 1 is equal to r squared plus r plus 2 times, and now I'm going to write them out individually like so, because then we can see what it cancels with easily. Okay, so now I look, well, what's canceling? R squared minus 1s, R plus 1s. So I'm going to FOIL and distribute for the following. Okay, so I would have r to the third minus r, okay, plus r squared minus r is equal to, now I distribute, I'm taking r squared times r to the third, r squared minus 1 will be negative r squared. R times r will be plus r squared. So it's negative r. And then my last piece, I have 2 times r, so plus 2r, and 2 times -1, so minus 2. Now I'm going to combine my like terms. On the left-hand side, there is no terms to combine, so I'm going to write them in standard form. So I would have r to the third plus r squared minus r minus 5. Remember, standard form is highest exponent to lowest. Just makes it easier to look at. So then I have r to the third. Those r squareds will cancel. Negative r plus 2r is just plus r minus 2. Now I'll see that I have r to the thirds on both sides. So if I were to subtract r to the third from both sides, they will cancel. Okay, and now we can see it's a quadratic. So I need to get everything onto one side because it's a quadratic. So I move everything to the left-hand side. So I'm going to subtract r and add 2. So my right-hand side is gone to 0. So I have r squared. Negative r minus r is minus 2r. Negative 5 plus 2 is minus 3 is equal to 0. Now I'm going to factor what multiplies to negative 3 but adds to 2, negative 3 and 1. Now to get my solutions, I set each piece equal to 0 and solve using the zero product property. So r is equal to 3 and r is equal to -1. Okay, now I check for my extraneous solutions. I plug 3 into my denominators. 3 squared minus 1 will give me 8, so we're good there. 3 plus 1 is 4, so we're good there. So this one is a solution. And you could plug it into the overall to make sure it equals out. Now I plug in -1. Right here I can see right away, -1 plus 1 is 0, so this one will not work. This is what you call an extraneous solution. All right, so that's it for example 6. If you have any questions, be sure to write them down so I can come back and answer them for you. Let's move on to example 7. Same idea, I need to factor my denominator. First fraction's factored in the bottom, so is the second. So my third one is really x plus 1, x minus 1. So it's the same as the last one. My LCD would be x plus 1, x minus 1. And just to remember, I'm going to write it as or. It's x squared minus 1, depending on which makes it easier for us. Now I go ahead and I'm going to distribute. So this time I'm not going to write it all out. I'm going to have 2 times. If I do this, my x plus 1s and my x plus 1s will cancel. So I'm only going to have times x minus 1. Minus, I'm going to write 1, times, now look at, I have an x minus 1 here, so when I distribute, my x minus 1s will cancel. So I'm only going to be left with x plus 1 is equal to negative 2 times, well, this is the same as x squared minus 1, so those will cancel, so it equals negative 2. Now it's nice and easy. I'm just going to solve from here. I distribute my 2, so I have 2x minus 2. Distribute the negative 1, so I have negative x minus 1 is equal to negative 2. I combine my like terms. And then I would add 3 to the other side. So we will get that x is equal to 1. Well, now I go ahead and I check to make sure I don't have any extraneous solutions. I plug in 1 here. 1 plus 1 is 2, so that's good. 1 minus 1 is 0, and we cannot divide by 0. So once again, this is extraneous. And we do not include extraneous solutions in our final answer. So there is an extraneous and there's no other options. So in this case, my answer is actually that there is no solutions. Okay, that's example 7. Let's go ahead and look at example 8. Same idea, I need to factor. So I can factor out a 3 from my first denominator, so I have n plus 1. Factor out a 4, I have n minus 1. And I factor out a 2, I have n plus 1. Okay, so I feel that it's pretty easy to see that I'm for sure going to have n plus 1 and an n minus 1. Now we need to decide what number do 3, 4, and 2 all multiply to. Well, if you don't know, we can break it down. This is 3 and 1, this is 2 and 2, and this is 2 and 1. So my least common multiple, or my least common denominator, would include 2 times 2, the lowest of the highest number of the number of numbers, and then a 3. Well, that's 12. Or you could have thought, well, I know that 12, 4, and 2 all go into 12. So that is my least common denominator. Now I'm going to go ahead and distribute. Taking this times this. I'm not going to write it all out, but I know I'm going to start with 7n times, okay, ignore these here, 12. Now let's look at it. If I have an n plus 1 here and an n plus 1, these will cancel, so I still have n minus 1, but that's still over 3. Minus, now in this case, I'm going to leave the 4 in the denominator, so it's going to be times 12. Now I have n minus 1, so those will cancel, so I'll be left with n plus 1 is equal to 3n times 12. Now if I look, I have n plus 1 here, so those will cancel, so I'll have n minus 1 all over 2. Now let's go ahead and see if the rest of the fractions will disappear or simplify to something easier. So I have 12 over 3, or 12 divided by 3, which is 4. 12 divided by 4 is 3, and 12 divided by 2 is 6. Okay, so now I'm going to have 7 times 4 is 28n times n minus 1, minus 5 times 3, so 15n plus 1, is equal to 3 times 6, so 18n, n minus 1. So now I'm going to distribute. This gives me 28n squared minus 28n. Be careful on this one, make sure you distribute that negative 15. So I have minus 15n minus 15 is equal to 18n squared minus 18. Okay. we should start to see it's a quadratic, so I'm going to go ahead and get everything to the left-hand side. So those will cancel, and I'm going to add 18. N. Sorry, I forgot to write the n, didn't I? There should be 18n times 1 is 18n. So this will give me 10n squared. Now I need to go ahead. I have 28n minus 15n plus 18n. That will give me a negative 25n. And then just bring this down. Minus 15 will equal 0. Okay. Now I can see I have a quadratic. But before I go ahead and try to factor that, I notice they're all divisible by 5. So I can factor out a 5. So I would have 2n squared minus 5n minus 3 is equal to 0. Okay. Notice that if I divide both sides by 5, that will disappear. Okay, and 0 divided by 5 is 0. So I really only have to worry about 2n squared minus 5n minus 3 equaling 0. So I'm going to factor that. I'm going to use guess and check. The reason this one's really nice to use guess and check on is because 2 is a prime and 3 is a prime. Okay, remember, to be a prime, it only multiplies by 1 times itself will give you that number. So 2, my factors of 2 are 2 and 1. So I would have 2n and 1n. Now my factors of 3 are 3 and 1. Okay, for my guess and check, I check these two. This gives me 3n. This gives me 2n. Is there any way using these numbers I can get to a negative 5n? Well, if they're both negative, I could. But would that work? Because if you think about it, this is negative 5, but then I would have to make these both negative, so that would multiply to a positive 3, not a negative 3. So that will not work. So what I need to do is I need to switch them around. I need to put 3 where the 1 is and the 1 where the 3 is. So I'm just switching them 1 and 3. Okay, that will change what I have here. So now I check it. This will give me n. This will give me 6n. Okay, well, can I get this to be negative 5? Well, if this is negative, and this is positive, well, now think, 1 times negative 3 is negative 3, and if I add those, I get negative 5. So there it is, factored with my guess and check. If you want to do grouping, you can. And now, same as before, I said each piece equal to 0 and I solve. So I have 2n plus 1 equals 0. And I have n minus 3 equals 0 because 1n is just n. I would subtract 1. So 2n is equal to negative 1. Divide by 2. So I get that n is equal to negative 1/2. I go ahead and move to my other one. I add 3 to both sides, so n is equal to 3. I plug both of these into my denominators, and I do not have any problems. So I have 2 answers. N equals negative 1/2, and n is equal to 3. Let's go ahead and look at example 9. This will be the last example we'll look at for this video, and then we'll finish up the rest of the notes on another video. Okay. So example 9. Okay, same sort of idea as before. We're going to go ahead and factor our denominators. This one is factored, so this one I can factor here. P plus 1, P minus 1, and this is really just P over 1. So my common denominator then would have to be P plus 1 times P minus 1, or as I did before, it's the same as P squared minus 1 to make life a little easier for us. So I take this and I'm going to multiply. I'm going to keep my numerator. So I have P squared minus P plus 1. Now if I multiply this, my P plus 1s will cancel, so I'm only left with P minus 1 is equal to, now I have P squared minus 7. Okay, if I take and distribute this, well, this has P squared minus 1, which is the same as P squared minus 1, so those will cancel. Okay, now plus, so this and this cancel, so I only have P squared minus 7, plus now I have P over 1. So nothing will cancel, so I'm going to write it as P squared minus 1 because that's the FOILed form of it, so I have P squared. Okay, now I'm going to go ahead and distribute. I would have P squared times P, which gives me p to the third minus p squared minus p squared plus p. Okay, now I'm going to go ahead and do the last piece, this times this, so plus p minus 1 is equal to p squared minus 7 plus p to the third minus p. Okay, now I'm going to get everything to one side. Okay, or let's go ahead and combine like terms first, I guess. So I have p squared, negative p squared, and negative p squared. So I have p to the third minus 2p squared plus 2p minus 1 is equal to p to the third plus p squared minus p minus 7. Okay, now I'm going to go ahead and notice that if I subtract p to the third from both sides, it's going to cancel out. And I will see that I am left with the quadratic. Okay, when I'm solving a quadratic equation, if I can, I would like to keep my p squareds positive. So it's negative here, so I'm actually going to take everything from the left-hand side this time and move it to the right-hand side. So I'm going to add 2p squared to both sides. I'm going to subtract 2p and add 1. So I have that 0 is equal to 3p squared minus 3p minus 6. I will see that I can factor out a 3. So I have p squared minus p minus 2. Same thing as the 5 from the example before. Okay, if I divide both sides by 3, those will cancel. So I have 0 over 3, which is 0. And then I can just factor this piece. Well, what multiplies to negative 2 but adds to negative 1? Well, negative 2 plus 1, that would give me. So I solve my answers. So I have p minus 2 is equal to 0. So if I add 2 to both sides, p equals 2. P plus 1 equals 0. So p equals negative 1. And I check. If I plug that into here, would I have any problems? Well, 2, this would give me 3. 2 squared is 4. 4 minus 1 is 3. So we're good there. But if I plug in negative 1, would I have any problems? Negative 1 plus 1 will give me 0. So this one is extraneous. So my only solution is p equals 2. Okay. We're going to go ahead and stop the video there for today. There will be one final part to finish up the notes. So go ahead, take a break. If you want to watch the next video, I would just recommend taking a 5-minute break. If you have any questions, write them down. Make sure you ask me tomorrow in class. Otherwise, have a great day, and I will be back with the third video. See you later.